with you. They get so much mad at me. Those guys get all the attention when stuff goes wrong. So they get a lot of negative attention. It's good when they get positive attention. But so anyone here heard of URL protocol before? Maybe, okay, that's fantastic. That's fantastic. And people here heard of Swizzling before? Maybe none of you. Okay, I apologize. So this is a talk about sort of, in many ways, the story of, we built our own sort of custom protocol that reduced latency on applications and improved security, perfect word secrecy, certificate pinning all the way out of the box and all that. And so we needed some glue code so folks could, put in the SDK into their application and it would just all work. So this is the story of an unfortunate series of events like that. So who am I? Well, that's me before I discovered Flux, the thing that makes your screen go orange. That's my manual Flux. And I'm currently the co-founder at the Community Phone Company, which is just a nationwide network where instead of having retail stores, we meet people in person. So it's a focus on service rather than retail. Before that, we co-founded Caffeine, which is much more relevant to this topic. So we're going to cover what is URL protocol, some reasons for caring about it, if you haven't heard about it, a quick example. And then there are some runtime gotchas that make you go absolutely crazy, and we'll cover 2 of them, and how to get out of there. And then that's all. So what is URL protocol? So it's a class, right? So we're already misled number 1, but it gives us very fine-tuned access over how URLs are loaded. So if anybody's ever worked with an HA proxy or some sort of proxy server, it's kind of like a distributed proxy server on every single client. It's very, very powerful. I'm pressing the wrong buttons here. So, or in more eloquent terms than me, if you are NS hipster fans in here, it's both the most obscure and most powerful part of the URL loading system. And why should we care? Well, a lot of stuff is a URL in your application. Stuff in your web views, API calls to your backend, if you're loading files, if anybody's here writing caches, by the way, at all, or I can't find anyone writing caches anymore. And all the third parties that you add to their applications who end up, calling home. So, for example, and I think there's even another talk right now going on about test design, but do people here write unit tests that involve network requests ever, kind of stuff? So a problem that we had, with network tests or tests that use the network is that it's not always, if you're offline, the test will fail, but really, the logic might be there. So we can stub responses so you can just return them without actually having to talk to the network and introduce all that TCP complexity. You can test the application when you don't want to test the session or the link layer stuff. So URL protocol obviously can help with that. And this actually happened to us. We were using this vendor and they promised that we would have a reliable and consistent schema, right? And then they go ahead and get a new domain and there's no forwarding and stuff. And luckily we were able to, with our URL protocol, make it work out. Or this happened to a buddy of mine. One of his billing frameworks was actually taking all of his users' locations and sending it off to somewhere, right? That's pretty crazy. It'd be cool if we could know exactly what our third parties were doing when we add them to the application. And it can tell you that. And if you are interested in really fine-grained control over web views, a lot of apps, will present, maybe the more secure ones will present a web view. URL protocol can give you very good control over how that stuff is loaded, and you can take a lot of responsibility from the server into your world. And so a quick example. So it's 3 simple steps to make a URL protocol. The first is we just subclass it. Then we override 4 very important methods, and we're going to talk about what those are. And then we just register with the URL loading system and go, hey, we're here, use us. And subclass, right? We subclass URL protocol, formerly NS URL protocol, right? Then we can begin overriding the 4 most important methods. So we have ken init, and that passes in the request that is currently being loaded. So we can see that. And so we're building a cat exterminator protocol. So what the goal of our protocol is, involves every time there's a request whose URL has the word cat in it, we're not going to let it load or talk to the network. So, if it contains cat, we're going to not return, we're going to return true so that we use our cat exterminator protocol for those requests. If we return false in ken init, the protocol is not used, right? We use the default, systems protocol, not our exterminator protocol. right? And then the second one is the canonical request for request, and this gives us the opportunity to modify the request in any way we see fit before actually doing the loading, but we're just going to send it right back up, unmodified. And then this is the most important method, the actual loading has to occur. So we're going to synthesize a response because we don't want anything that has the word cat in it to actually talk to the network. So we're going to make the HTTP response here, add an exterminated status right into its headers, and then we're going to pass that response back to client. So client is sort of the window through which we send stuff back and appears inside our block from a data task, and you'll see what that means. But we're sort of, we have this window, and stuff that we kick back into self.client.URLProtocol, the response is what will come out of the session on the other side. And then if there's an error, we have to obviously communicate that error back so the top level can handle it correctly. And then when we're done, we have to finish, let the system know we're done loading. Otherwise your request will hang and you'll never actually get a response. You'll get these weird timeouts and you don't know why. And then stop loading. But for us, you'd want to do some cleanup normally here, but in the case of us, it's a very simple, admittedly contrived cat extermination. We don't need to stop any loading because there is no loading. We're just synthesizing a response, passing it right back to the system. So we have canonic, do we want to use this protocol for the given request, canonical request for request? Do we want to modify it in any way? Loading, actually doing the loading, error handling, all that stuff, and then stop loading when we're done. And the third step and final step, in our app delegate, we just add URLProtocol.register class and we pass the name of our protocol. And that tells the system that we have a custom protocol that is available to use. And so if we don't have that register on the app delegate, canonic will never be called, right? So you need to make sure that you tell the system that we're here, we have a protocol to use it. So those are the three steps. So the results, what does this actually look like? Well, if we just make, just a regular session, we create a data task, we have a URL with cats in it, and then we are going to print the cat status when it comes back in, and then we're going to start the load. So right when this happens, assuming we've registered it, assuming we have the protocol, we drop into our protocol, and we're in canonic, right? And so we first, this is control flow, this is an area of control flow. Does it contain cat? Yes, it does. Google.com/cats. It's not a thing, but it's a thing for now. We're going to return true. If return true, then we come down to start loading, right? We synthesize our response. We pass it back into the URL loading system, the response right there, did receive response. You also get some cache storage functionality here, but we don't have to go into that. And then we're good, we finish loading, and then immediately like that, we're back here, right? And so we've sort of, it's almost a sort of virtually zero latency because we synthesized the request on the client, and now we're back here. And then we're going to print it, and it's exterminated, right? So that's interesting. You'd think this would actually talk to the network, just looking at this, not knowing what URLProtocol does, but it doesn't even leave the phone. So the three steps there, just to recap again. And within this, if you really want to sort of dive into the world of URLProtocol, there are a couple of, unfortunately, obscure things that will totally destroy or break your application if you're not careful. And one of those, at Caffeine, which is where I used to work, we had this custom protocol, and we needed URLProtocol so we could properly interface in the application. So we essentially replaced TLS and HTTP and used URLProtocol to seamlessly communicate back with the client, right? And this was written, myself and my girlfriend were sleeping on an air mattress over in the HubSpot building for a week, just trying to get this stuff to market. So we were discovering these things as they were coming up, and it was like a living nightmare, and you'll see why. So if you use URLProtocol with any sort of body data, so anything that is taking data from a client, sending it out there, doesn't work. Same if you're using a third-party networking library, as most applications do, which is the use case we really cared about. And the reason that the body data stuff, non-item potent stuff doesn't really work is because the HTTP body is set to nil. And this is because an Apple engineer somewhere, once upon a time, just left the code, set HTTP body nil in there. And I'll show you. So what happens? What does this bug mean? We create our session, we create a request, we set the HTTP body, and on the right, let's assume that it's non-nil. We get a picture of a cat, we set it in there. Then we load it, we resume it, the request starts. And then inside of our protocol, can init, we're going to assert that the HTTP body is non-nil, right? And we just set it, right, to an image, so it should totally be there. But of course, this crashes, totally crashes. And so, those are the two radars, they're still open. And this is in there. So what you have to do is you got to swizzle your way out and swizzle your way back in. So when this is called, there's just no change that's made. Yours truly. That's the first one. The second one relates to Alamofire AF networking. And when we are registering, remember we were in the app delegate and we had to do the URLProtocol.register. You guys remember to let them know that we were around? The caveat is that that registration only works if the URL session is a shared session, right? And third parties rarely use shared sessions. And so, for example, if we were using a default session configuration like Alamofire does, it's a moot point even if we register URL protocol in our app delegate. Doesn't matter, right? Even though we register, there's no effect. We're invisible to cat extermination. Totally fails. It's never called. Doesn't even know our protocol exists. Crashes, right? So it didn't see our protocol. So in order to allow for non-shared sessions to work, if it's our code, we can do something that's easy. And the easy thing is to just append the protocol to the class. But of course, if you're using Alamofire, you're not going to go in an Alamofire and modify their source code directly. I mean, that's very hard to maintain. So we can't actually append it in there, right? Unless we've made a pull request to Alamofire or did some special feature, and for all the other networking libraries as well. And so in spirit of keeping modules sort of independent of one another and everything sort of independently maintainable, we have to figure out a better way. So it'll work, if we can do that, if we are the ones who own the session configuration, if it's in our namespace. But third parties, it's another thing entirely. Right, and so that's the second problem. And so the how to escape sort of unbroken, right? We have to swizzle our way in here. And people seem to sort of, when the people heard of swizzling, people who actually write swizzling code in production ever and ship it. Yeah, it's scary. Yeah, no, it's serious business. And so it's a runtime hack. It relies on the dynamic nature of Objective-C, and it swaps implementations, right? So what's actually happening at runtime is, for example, if we wanted to count how many times print is called in our application, we could swizzle so that when instead of calling foundations print, we call our custom print, we just have a counter right before we actually call print. So it's a way to get yourself into other people's methods, right? And it looks just like a bug. So when they initialize a session configuration, URL session configuration.default, we want to instead return our session where we append the protocol into it. So we did this by extending URL session configuration, and we make an actual function that does the swizzling itself, right? And you do this, you get both selectors, you get the methods from the selectors, and then you exchange the method implementations. And so what we're doing here is you see, URL session configuration.default, we're going to swap those methods with URL session configuration.config with exterminator. And that's right down here. So we're actually going to make it so when you call URL session configuration.default, you're not getting the default one, right? You're actually getting ours. And so we set the config. So we want to make a URL session configuration.default. But this looks totally like an infinitely recursive function, right? But remember, at runtime, this value of config with exterminator is going to be swapped with the URL session configuration.default. So at runtime, this is semantically equivalent to URL session configuration.default, right? But looks terrible, right? Absolutely horrendous. And then this is where we do our modification, where we append it, right? And then we return it, right? And then, we can call, in our app delegate or wherever, the actual swizzling of it all, so that when anybody in the application calls URL session configuration.default, they will get a default session configuration with our protocol appended to it, right? And yeah, now works with third parties, right? So we can just remove that and config, it has our protocol added right into it because we did the swizzling, so it's all there, right? So URL protocol is, it's pretty powerful and broadly applicable. You know, there are anything you can do on a proxy, essentially you can do with URL protocol. You subclass, you override the 4 methods, and you register it in the ideal case, and then there's some undefined behavior at runtime that you have to be very careful of. And you can fix it with swizzling. So thank you everybody for listening, and I really appreciate your time. Any questions? Maybe?
Question?
Oh, sure, right in the back. Oh, yeah, yeah.
So this is just within your app, I assume, right?
So this is just within your app, and I'm wondering if you, and obviously, right, that's all stuff you're doing, but is there, I've noticed that there's like a Charles proxy now for iOS. Do you know how that works, if you're familiar with this at all? Is it related to this kind of?
Sure. Well, Charles is it just tells you what's going on behind the scenes, and in many ways, you know, Charles is good for understanding what's going on. You know, this allows you, you know, in your development environment. It does not tell you what's going on in a production environment, right? So you could think about this like Charles in terms of what insights it yields to you at runtime, right? But you're right, if you're just understanding, you know, basic debugging, you know, what's going on the network, and you don't care about how it behaves, you know, in production necessarily, yeah, you could use Charles.
Yeah, no, I was wondering if you just knew how they implemented it on iOS, because they now have Charles running on, you don't have to proxy to like another machine, it's actually running, I think, on the device.
You're talking about
it seems
an
like
app?
it gets out of the sandbox somehow.
Yeah, well, are they using a VPN configuration?
Yeah, I don't know,
Yeah.
I was just wondering.
Yeah, that's a different set of APIs. Yeah, I assume they're using a VPN, the VPN
Okay,
stuff. Yeah.
thanks.
Yeah, sure.
So, does this only work because the underlying NSURL protocol is written in Objective-C?
So it's because we use the, I don't think so. I mean, that would relate, Objective-C runtime would relate to dynamic, you know, swizzling and so on. NSURL protocol, as long as just Apple keeps it around.
I guess more your fixes. In the
Oh yeah, the swizzling, right. So yeah, that's totally, like if everything were a static dispatch and like things like inlining existed, this wouldn't work. I mean, what's going on behind the scenes, you know, when the program is looking in memory for the instructions to execute, you know, we're just pointing, we're remapping. So like in C, this probably wouldn't exist. You know, it totally relies on the dynamic nature of the runtime, 100%. But not because it inherits from, or not because NSURL protocol has the add Objective-C, but because the runtime is a thing, right? So yeah, it's not going away anytime soon unless other people know things more than I do.
Two things. You said there's the radar for the body data being nil. That's still an issue? There's no way to like swizzle around that, or is there?
Oh, so yeah, there is. And I didn't show that, but and I sort of briefly pointed to what you'd have to do, and I'm more than happy to show you like our implementation after. What you have to do is you have to swizzle the set HTTP body nil to just a method that does nothing, and then swizzle it back, right, when you need it later, right? So it's a bit more complicated. I didn't go into it here. Because like when do you swizzle back and like how do you manage the swizzling? Most people don't swizzle at runtime. Usually that's like a set thing. But in order to do it, you have to like repoint stuff.
And I'll mention that with Alamo, at least in our code base, we have there's a way to provide your own URL session configuration now.
Then you
with
say
Alamo Fox.
Totally. Then you say for us we were just a third-party library, and so in spirit of reducing our API surface, you know, we did
Makes sense.
Cool.
So does NSURL protocol at all touch DNS? Like if there's my DNS has been poisoned and my domain is not pointing where I want it to point, is there anything that I could do with NSURL protocol, or is that a whole different?
No, totally. I mean, well, what you can do just most simply is just, you know, change the URLs in however way you want. I mean, but regarding DNS particularly, it does yield particular insight. People care about their DNS latency, for example. URL protocol and friends provides really insightful information there. But yeah, I mean, it gives you great flexibility.
So for example, like in NSURL protocol, could I capture the IP address that's returned for the domain and see if it's correct or if it matches up with what I expected to?
You could. I mean, you'd have to then resolve on the client, I guess, what IP the DNS is pointing to. But, yeah, I'm sure there's a way.
Cool, thank you.
Yeah.
Question?
Any other questions?
Thank you.
Awesome, thanks so much, James. So James will be chilling in the Wayfair Lounge if you have more in-depth questions that you want to talk about for method swizzling. I know I have no idea what that is, so I'll definitely be talking to him about it. And also, lunch is arriving, and so how lunch works is we'll have lunch on the first floor in the bar area, like right out in the hall, and then also on the second floor, there will also be lunch, so feel free to get out there and get your lunch on. Thank you so much, James.